Hello dear students, this is Jambagi welcoming you all for another online lecture. Till the last clip, I used the simple tool of teaching learning process. I am trying to improve that tool for our better communication. That's why I am taking a bit different approach. Hope you are liking that. Before going to that technique dear students, I insist you that please skip the video of the previous one, that is on magnetic effects of electric current if you can, because I'm bringing the same thing here but in a different method as I'm saying this. So let us focus on the new technique. Hello dear students, in this class we are learning the 13th chapter, that is magnetic effects of electric current. In this topic, you are learning basics of the magnetism, that contains magnetism and magnet, story of the magnet, types of magnets, bar magnet and its properties, magnetic field and magnetic field lines of a magnet, properties of the magnetic field lines. We are also learning the main point, that is magnetism due to current carrying conductor or magnetic effect of electric current. So in that concept we are learning the Oersted experiment, magnetic field due to straight conductor carrying current and right hand thumb rule, magnetic field due to a circular loop carrying current, magnetic field due to a solenoid carrying current. We are also learning force on a current carrying conductor which is placed in the magnetic field. Here we are taking Fleming's left hand rule along with the electric motor, and the next main point will be the electromagnetic induction, where we are learning the process of electromagnetic induction in two different sense. One is by coil and magnet experiment, and other one a coil and another coil carrying current. We are getting the electromagnetic induction due to those two steps, and we are also learning Fleming's right hand rule, and also electric generator. And in the end, we are taking the last part, that is the domestic electric circuits. These are the points which we are discussing in this topic. Let's take the basics of magnetism. So let's define first what exactly the magnetism, and later we will take the definition of a magnet. The property of an object or a body, or the phenomena by which it attracts a piece of iron or steel, is known as magnetism. Magnetism is the property of an object or the phenomena by virtue of which the body can attract the piece of iron or steel or such substances. That is known as magnetism. So the object possessing the magnetism is known as magnet. Okay, the object or a body which is possessing the magnetism is taken as a magnet. Okay, so magnetism is the phenomenon and magnet is the object which is doing that. I hope you are getting the definitions of magnetism and magnet right. So here I am collecting the few pictures of magnets which you are familiar. Take a look on those magnets. So let's take the story of magnetism. So how the magnetism is occurred. Okay, there is an island called Magnesia in Greece. There is an island called Magnesia in the country of Greece. Years ago, shepherd here complained that their wooden shoes with nails stayed stuck to the grounds. By that, they are unable to walk further. So this was the complaint made by the shepherds in that region. So the people search what exactly the reason behind that event. So because of that, the discovery of magnetism took place. So how this magnetism is related to the presence of magnetic fields, if you're asking, actually this Iceland has lots of magnetic ore deposits. Because of that magnetic ore deposits, their nails stuck to the ground. Okay, this is the story behind the magnetism, which you are already aware, I believe. Now, let us take the different types of magnets. So there are two types of magnets. One is the natural magnet and other one is the artificial magnet. Okay, let's take those two one by one. Natural magnets. Natural magnet is an ore of iron that attracts the small pieces of iron, cobalt, nickel, steel, so on towards it. A natural magnet is the one that is the ore of the iron that can attract the pieces of iron, cobalt, nickel towards it. So a natural magnet shown in two different pictures in your screen. So that is the example of natural magnet. It is usually an iron oxide named as Fe3O4. So it is the oxide of iron or iron oxide, and the molecular formula of a natural magnet is taken as Fe3O4. Magnetite or lodestone is a natural magnet. The above pictures are showing the magnetite or lodestone. Those are the natural magnet existent. Let's take the artificial magnets. A magnet that is prepared artificially, that is nothing but artificial magnets. Artificial magnets are man-made. They are meant to be for specific purposes. Therefore, an artificial magnet is the magnet prepared artificially for particular purposes. Examples: bar magnet, cylindrical magnet, horseshoe magnet, U-shaped magnet, a ring magnet, button magnet, and so on. All those magnets picturized in this case. Please take a look on those different types of or different kinds of artificial magnets shown in this picture. Dear students, I hope you are having the basic of magnet and story of magnet as well as different types of magnets. Okay, let's take the important magnet that is called as bar magnet. Bar magnet is a simple magnet which is used for many purposes, and meanwhile we are taking this for our simple understanding. So we define a bar magnet as it is a rectangular piece of an object which is shown in this picture. A bar magnet is a rectangular piece of an object made up of iron or steel or any other ferromagnetic substance or ferromagnetic composite that shows permanent magnetic properties. Remember, ferromagnetic substances or composites showing the permanent magnetic substances. Okay, permanent magnetic properties. Ferromagnetic substances we call iron or steel as. Okay, there are so many ferromagnetic substances present. Anyway, a bar magnet is a rectangular piece of object made up of iron or steel or any other ferromagnetic substances. Generally, it has two poles, north and south respectively, such that when it is suspended freely, the magnet aligns itself to that northern pole, points towards the magnetic north pole of the earth as well as south. Okay, it has north and south poles such that whenever you are suspending that magnet freely, it finds the geographic north and geographic south of the earth. It points towards that. It is one of the property. Remember, which we are learning in the next few minutes. So let's take the properties of magnets. First one, magnets attract magnetic substances like steel, cobalt, iron, nickel, and so on. So magnets attract the magnetic substances like steel, cobalt, iron, and so on. So this is known as attractive property. Take a look it in the picture here. So there are some nails here. So they are attracted by the bar magnet, which is shown here in this case. And in also in the second picture, we are having the U-shaped magnet, which is attracted by groups of nails in this case. Okay, the magnets attract the magnetic substances like steel, cobalt. That property is known as attractive property of the magnet. So second property of the magnet is as follows. When a bar magnet suspended freely. So in this picture we are taking the bar magnet which is connected to a stand and it is suspended freely. On the other hand, we are having the directions north, south, west and east respectively. So whenever you are doing that, means you are suspending the bar magnet freely. It points in the north and south direction. The tip which points towards the geographic north is called as north pole of the magnet, and the tip which points to the geographic south is the south pole of the magnet. Remember, geographic north and geographic south are the Earth's magnetic poles. We are taking it as Earth's magnetic poles. Remember, we are always taken into consideration that Earth is a huge magnet. So Earth has its own north pole and south pole. Therefore, we are calling it as north pole, that is geographic north of the Earth, and geographic south of the Earth. Whenever you are suspending bar magnet freely, so it finds the north-south direction of the Earth. Okay, so the point which is making towards the geographic north is taken as north pole of the magnet, and the tip which point towards the geographic south is taken as south pole. This is also known as a directive property of the magnet. Okay, this is also known as directive property of the magnet. There is a repulsive force when north poles or south poles of two magnets are brought close together. So whenever you are bringing the north pole or south pole of two different magnets brought close to one another, it is going to repel each other, and conversely there is an attractive force between the north pole of one and the south pole of the other. So that is shown in this picture. Whenever you are bringing the two same poles, say in this picture north north, whenever you are bringing north north pole or sometime south south in, they are going to repel each other, repel from one another. Whenever you are bringing north and south pole of the magnet, two different magnets nearer to each other, they are going to attract. This states that unlike poles attract each other, whereas the like poles repel each other. So let's take one more property of the bar. We cannot isolate north or south pole of the magnets. If the magnets are broken into two holes as shown in this picture, if you break this magnet into two, yet again it is forming the north and south. So whenever you are cutting the magnets, it again forms the north and south, and that process so on. Only the change happening in this case is the magnetic property or the field is going to reduce all the time. In case of electric charges, there is a chance of electric monopole, but in case of magnet there is no question of monopole, means single pole. In this case it is impossible. I hope you are all getting these things right. I hope you enjoyed this clip. Do comment by using my WhatsApp number for your opinion. Okay, if you like this method, I will continue definitely. So we will meet you in the next clip. Till then, bye bye.